The other electronic components that we're going to be looking at is the LCDs, the ICs, and the IC sockets. Now, LCDs and IC sockets are very important, but they are different components. I just group them together. LCDs means liquid crystal displays, which means there's a crystal and there's liquid, and then the alignment or disalignment of the liquid crystals based on the kind of voltage that is applied to them can be used to display alphabets, numbers, and other things. They are used to display numbers, alphabets, like the ones on your keyboard, and even text message. And LCD can display a text message. ICs means integrated circuits, and then the IC sockets are used to connect ICs to circuits without having to solder the IC itself. This is very, very important. When you're building a circuit and you have to deal with an IC, don't solder the IC directly to the circuit, because if that IC, after you solder the IC and maybe there's a reason for you to change the IC later on, or maybe the IC becomes faulty, you have to now start desoldering the IC, the many pins, the whole circuit will become rough, the IC will get damaged, even the new one you're putting might be subject to heat. And when you heat, there are some ICs that when you heat them with an iron, they spoil easily, because most beginners are not very, very experienced with soldering. So there are a lot of reasons why you should use an IC socket. So an IC socket saves you all the stress of damaging the IC or having to desolder an IC after soldering it. Trust me, it's a lot of work to desolder an IC. It's a nightmare. So I'll be showing you all these things in the next video. Alright, here we have a lot of other components. We've been going through most of the common electronic components, like the resistors, the LEDs, the switches, the variable resistors, and the batteries. But these are components that you will most likely meet during the course of your adventures in electronics or embedded systems. So I'm not going to spend time on them. I'm just going to run through them as fast as I can. You already know this is your breadboard. This is an LCD display. It has some pins behind it. You connect these pins to your circuit and a microcontroller, and then this LCD can display alphanumeric characters on the screen. Alphanumeric, which means from any alphabet from small letter A to small letter Z, capital letter A to capital letter Z. Many kinds of symbols and anything you can have. Most of the ASCII characters, it can display them. So these are ICs, and this is an IC socket. Alright, let's start with the IC. This is an IC. This is currently a Max 232 IC. An IC is an integrated circuit. It means integrated circuit, and each of these pins have their numbers. So how do you know the numbers of the pins? You simply look at the IC, and then if you look at the IC closely, camera, if you look at the IC closely, you will see that there's a mark, there's a dot or a U shape on the IC, either one of the two or both of them. You will definitely see at least one. In this case, where you have the dot, the pin that is directly beside the dot is the pin 1. So you count the pin directly at but beside the dot is pin 1. So how do you know which way to count? Do you count like this, or you count pin 1, 2, 3, or you count pin 1, 2, 3? How do you count? It's simple. If you look at the U shape, think of how you will actually draw letter U in real life. you start from the left. You start from the left and then go to the right. So that's exactly how you do the IC counting. You count starting from the left and you form a U shape like that. You don't do you don't form you don't go up. You go down when you want to draw, when you want to write U. You go like this and then you come back up. So that's how we're gonna count the IC. Starting from here, which is pin 1, you go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 5, 7, 8. And then you go 9, 10, 11, 12, 13, 14, 15, 16. So this is a 16 pin IC and this is pin 16. This is pin, what pin is this? This should be, let's see, what pin is this? 10, 11, 12, 13. This is pin 13. Sorry. 9, 10, 11, 12. This is pin 12. This is pin 5. This is pin 1 because of that point. So the point allows you to know where to start counting from. This is another IC. But in this case, this is another IC. This is another IC, but in this case, you don't have any U shape. You just have the dot. That pin there is pin 1 because of the dot. I'm following that U shape that we discussed about. This is going to be pin 1, pin 2, pin 3, pin 4, 5, 6. This is an optocoupler IC, by the way. Alright, now when you're dealing with ICs, it's very painful when you finish soldering an IC and then you find out that the IC is bad, or you have any reason to change the IC. It's going to be very difficult to change that IC. So what we'll do instead, we use something called an IC socket to work with ICs. The IC socket is like an IC itself, but it actually doesn't do anything. All it does is to connect the IC to the circuit that you want to use. So if you put an IC, you can put an IC on top of here and then remove it easily anytime you like, and you can put it back whenever you like. So it makes so you don't have to start desoldering the IC when you find out that you want to change it along the way. So that's why.